Hey everyone, and welcome to The Explainer. I'm so thrilled to have you with us today. If you're a focused learner looking to completely demystify the journey of building programmatic generative AI applications, well, you are in the exact right place. We're going to go way beyond just typing questions into a web browser. Today, we're literally opening up the hood to see how data scientists and developers actually engineer AI systems using Python, APIs, and some really advanced prompting frameworks. We've got a lot of ground to cover, so let's jump right in.
Here's our game plan for today. We'll start with core concepts and setup, transition over to mastering prompt engineering, and then look at defining context and roles. After that, we'll unlock the power of prompt chaining, and finally, wrap up with LangChain and AI memory.
All right, part one, core concepts and setup. Let's get to it.
So, to really get a firm grip on the modern generative AI landscape, there are basically four essential concepts you absolutely have to know. First up is prompt engineering, which is really the art of crafting precise, context-specific instructions. Then there's LangChain. Think of this as an array of tools and components that you can just plug and play based on your requirements. Third, we have LLMs, or large language models, which use deep learning and neural networks to actually process and understand natural language. And finally, code generation, which is using these tools to automatically generate functional text and code.
Now, speaking of code generation, let's talk about the heavy hitters dominating the data science space right now. Obviously, ChatGPT gets a ton of the mainstream buzz, but tools specifically built for generating text and code, things like Google Bard, GitHub Copilot, and Amazon Code Whisperer, are absolute game changers. They essentially act as your highly intelligent, always-on pair programming buddies.
Okay, let's get our hands a bit dirty. Your technical journey usually kicks off with some simple, secure Python code. You run a pip install for the OpenAI library. We're pinning version 0.28.1 here for stability. But notice the second line. Security is absolutely crucial. Instead of just hard-coding your private API key, you securely fetch it using a method like userdata.get for your OpenAI_key. You're now safely wired up and ready to talk to a supercomputer.
So how do we actually converse with it programmatically? We use OpenAI.chatCompletion.create, and we pass our messages in as a dictionary. When the AI answers, it sends back this massive, highly structured data object. To extract just the readable text that we care about, we drill down into the very first index of the choices array and grab the message content. It's like finding the exact coordinate of the AI's actual answer.
And what kind of things are we asking the AI to do? We'll take a look at this classic programming test case. A Python function to determine if a number is prime, right? It's called def_prime. It checks if the number is less than or equal to 1, returning false, and then loops through the range up to the square root to check the modulo. In data science, you're going to use AI all the time to generate boiler code just like this, or to debug it, or even to write unit tests for it.
Moving right along to part two, mastering prompt engineering.
Getting exactly what you want out of an AI isn't just magic. It follows a pretty strict four-step iterative loop. First, you conceive the idea. Second, you implement that idea into a draft prompt. Third, you experiment with different combinations. And fourth, you analyze the output. If it's not perfect, you loop right back to step one. It is very much a continuous cycle of refinement.
And honestly, this brilliantly illustrates why AI isn't coming for your job just yet. The system is only as good as the human steering it. To be a great prompt engineer, you need real human skills. You need creative questioning to tackle problems from new angles. You definitely need critical thinking to evaluate if the AI's answer actually makes sense. And most importantly, you need subject matter expertise, or SME. An AI can write a script, sure, but only an SME knows if it actually solves the business problem at hand.
When we're engineering these prompts, we're basically asking the LLM to perform one of three core actions. The first is to infer, like giving it a block of text and having it run sentiment analysis to tell us the mood. The second is to transform, taking existing text and maybe proofreading it or checking the spelling and grammar. And the third is to expand, where we give the AI some strict guidelines and ask it to generate completely brand new content.
Which brings us to part three, defining context and roles.
Think of the AI like a brand new employee. You never just say write a report and walk away without giving them any guidelines, right? You need to give the AI context. Provide your background info and preferences. Tell it the exact response format. Is it an email, a summary, or code? Give it boundaries on the response length, like brief or detailed. And finally, give it a personality by dictating the tone, creativity, and style. To actually structure all that context within the API, we use roles. And you have to understand the fundamental difference here. The system role is basically the boss. It sets the overall behavior and the strict rules. The user role is you, and the assistant role is the AI. So while the user and assistant are handling the conversational back and forth, that system role is running in the background, ensuring the AI never breaks character.
Now, let's look at some best practices to make your prompts bulletproof. Always use clear and specific instructions. But here's a really cool technical trick. Use delimiters. If you want the AI to analyze a block of text, put that text inside triple quotes or brackets, like triple quotes, open bracket, review, close bracket, triple quotes. This literally isolates the data so the model doesn't confuse your instructions with the text it's analyzing. Also, tell it to validate if conditions are met and always mention examples to the tool so it knows exactly what good output looks like.
All right, part 4, the power of prompt chaining.
So why chain prompts together instead of just writing one giant, complex paragraph? Well, it gives you some massive advantages. It drastically improves your outcomes, it gives you transparency, control, and makes collaboration easier through task decomposition. Plus, you get to explore alternative prompt strategies, compare parallel downstream effects, and, maybe best of all, you can easily debug unexpected model outputs by isolating and unit testing different links in your chain.
And this brings us to the golden rule of chaining. Decompose into 3 steps, or 4 steps, whatever it takes. The point is, instead of saying, research this topic, write a blog post, and format it for social media all at once, you break it down. Prompt 1 does the research. Prompt 2 takes prompt 1's output and writes the blog. Prompt 3 takes the blog and formats it. Doing it step by step is just so much more reliable.
And finally, part 5, LangChain and AI memory. This is where things get really fun. Let's define what LangChain actually is. Basically, it's an array of tools, components, and interfaces functioning as a plug-and-play architectural framework based on your requirement. Think of it as the ultimate glue. It seamlessly connects your prompts, your models, and your external data into one single, cohesive program.
What's amazing is how LangChain just abstracts away all the really deep complexity. Instead of wrestling with bulky native API calls, you just write something like from langchain.chat.models import chat OpenAI. You assign chat to chat OpenAI, and boom, you're set up. You get to focus entirely on the logic of your application, not the repetitive boilerplate code.
But here is the million-dollar question. Standard API calls have total amnesia. Literally, every time you send a prompt, the model has completely forgotten the previous one. So, as we're chaining tasks together, how do we store generated content so our AI actually remembers the context of the conversation?
The answer? LangChain's memory modules. You can easily initiate a conversation buffer memory to fix this amnesia. And you have options. You can use a conversation buffer to store the raw history. You can use a buffer window to store just the last few interactions. A token buffer limits memory strictly by token count. And my favorite, conversation summary memory, actually uses the AI to continuously write a summary of your history in the background.
Wow, we have covered some serious ground today, from setting up our API key to understanding delimiters and the prompt engineering loop, right through to using LangChain to chain prompts and give our AI memory. You now have the exact architectural building blocks that professional developers use. So I'm going to leave you with this. Now that you can engineer precise prompts, chain them logically, and totally cure your AI's amnesia, what complex real-world application are you going to build first? Thank you so much for hanging out with me for this explainer. I really hope you learned something valuable today.